At the end of the last video, I said that that was the first arithmetic properties video, and I said there would be a second one. I am a man of my word. Here we go. We're going to talk about 3 more properties, aptly titled number 4, number 5, and number 6. Number 4 is the identity property. And let's go ahead and dive into the identity property. A lot of these are going to be common sense, but it's still good to talk about them. We don't have to memorize the title of them, don't worry about that, but we have to memorize the rule because these basic mathematical rules are important to our foundation. So even if you know these already, it's still good to talk about them. So the first rule is that if you add 0 to something, it doesn't change what that thing is. A plus 0 equals A. It doesn't change it. So a real example with numbers, 5 plus 0 equals 5. I told you these were going to be kind of common sense, or a lot of them are. And remember, it doesn't have to be A plus 0. It could also be 0 plus A. That's the commutative property that we talked about in the previous video. It could be 0 plus 5. There's 2 parts to the identity property. This is part number 1. Part number 2 is about multiplying by 1. So if we do 1 times A or A times 1, remember the order doesn't matter with multiplication, it just gives us the original thing, which is A. So for example, 9 times 1 or 1 times 9 is going to be 9. So that's the identity property. Basically, the identity property in a nutshell is the thing doesn't change. That's the identity property. Let's talk about the inverse property. The inverse property, you can kind of think of it as canceling out. So for example, if we were to add the negative version of something to that thing, they cancel out to get 0. It's like matter and antimatter. If you add them together, they just poof and they're gone. So one example would be 3 plus a negative 3. They cancel out and you get 0. Also keep in mind, that's the same thing as 3 minus 3. You don't have to say 3 plus a negative 3. It's also 3 minus 3. So that's the first part of the inverse property. The second part is if you take a thing, in this case A, and you multiply it by 1 over that thing, in this case 1 over A, the 2 A's cancel out. You can think of the 2 A's canceling out. Here, if we get my marker here. So this A cancels out with this A, the matter and the antimatter, boom, poof, they're gone. And what you're left with is the 1. Now keep in mind though, this does not work for 0. And the reason why it doesn't work for 0 is because if you actually write it out, you would have 0 times 1 over 0. The problem is you're not allowed to divide by 0. It causes the world to explode. Don't do it. We'll talk about why you can't do that later. That's not what this video is for. Just remember, you cannot divide by 0, never, ever, ever, unless you want to see the world get destroyed. Let's look at an example. The example we have is 3, which is that thing that we're talking about, times 1 over that thing, 1 over 3. The 3's are going to cancel out, and of course, what you're left with is just the 1 right there. So that is the inverse property. Let's finally talk about the last one, the 0 property. Again, a lot of these are just kind of common sense. A times 0. So if you multiply something by 0, you get 0. Now remember, if you add 0, you keep the original thing. But if you multiply by 0, oh, boom, you just get a 0. But the question is why? Remember, multiplication is a short form for addition. They're kind of the same thing. So what this is saying is we're adding 0 to itself 7 times. So we have 0 plus 0 plus 0. Oh, those are actually pretty good zeros. Sometimes my handwriting works and sometimes it doesn't. It comes and goes. It's like good hair days and bad hair days. Okay, 0 plus 0, is that 7? No, that's 6 right there. Okay, so obviously this is going to equal 0. But remember, we don't have to think of it as adding 0 to itself 7 times. We could think of adding 7 to itself 0 times, in which case we just have nothing, right? Because if we're not adding it at all, you're just left with nothing. So in either case, you get 0. So that's the first part of the 0 property, which is pretty straightforward. I think most of us understand that, at least intuitively. This one needs a bit more nuance. If we were to say A times B equals 0, and keep in mind, we don't know what A and B are. They are variables. They could be anything. And we'll talk about that later in algebra. But just for the time being, what can we conclude from this AB equals 0? Well, there's possibilities. Possibility number one is that A equals 0 and B does not. So for example, maybe B equals 27. 0 times 27, of course, is going to be 0. The second possibility is B equals 0, but A does not. Maybe A equals negative 100, in which case it still equals 0. Or the third possibility, they both equal 0. 0 times 0 is indeed 0. If you multiply anything by 0, even if the A is 0, you're going to get 0. Now, which possibility do we know to be true? We don't know. It could be number 1, it could be number 2, or it could be number 3. If we were to do something like this, 4b equals 0. In this case, we can say for a fact with certainty that b equals 0. But in this case here, where they're both variables, it's one of these three possibilities, but we don't know which one. So those are the three properties, or at least the three properties of arithmetic properties number 2. We have the identity property. Think of it as things don't change. If you add 0 to something, it doesn't change. If you multiply something by 1, it doesn't change. The inverse property, think of it as canceling out. So for example, if you add the negative version of something to itself, you get 0. 3 plus a negative 3 is 0. Or the multiplication version, if you do 3 times 1 over 3, the two 3's cancel out and you're left with 1. Don't forget, it doesn't work for 0 there. And then finally, the 0 property is if you multiply anything by 0, you get 0. Doesn't matter what it is, could be anything. And if you have these two variables, a, b equals 0, three possibilities exist. Either a equals 0, b equals 0, or they both equal 0. Cool.